This section in the probability unit is called dependent events. We saw with independent events that you could find the probability of each event and multiply them together to get the total number of possible outcomes of the combined events. So if we had a problem like this, where you're asked to find the probability of getting a blue and then the probability of getting an orange, you would multiply those as 2/5 times 3/5. But we're going to switch our gear a little bit, switch our gears, and now we're going to look at what happens if when you take out the first marble, you leave it out. So you have some keywords that are highlighted in these directions. There are 3 orange marbles and 2 blue in a bag. If 2 marbles are drawn, find the following probabilities if the first marble is not replaced, not put back into the bag, before the second marble is chosen. So this time, when we find the probability of a blue times the probability of an orange, we'll still be doing that, but our probability of our orange is going to change. So when we take the probability of the blue out, we still have 2/5. Now, that blue marble is gone. So how many orange marbles do we have? 3 still, right? That hasn't been affected. But how many total marbles do we have now? We just have 4. So the total number of marbles has changed. I'm going to cross cancel. And what do we get for our total probability? 3/10. Now let's look at our second problem. Here it says find the probability the first marble is blue and the second marble is blue. So finding probability of blue times probability of blue. The probability of blue is 2/5. But now again, we just took a blue one out and we left it out. So that's gone. Now how many blues do we have? We only have 1 out of how many? 4. So now your problem becomes 1/4 times 2/5. Cross cancel, and what do you get? Oops, 1/10. So here's the notation when the outcome of one event affects the outcome of the next event. So probability of A, you find the probability of the first event as usual, and then you find the probability of the second event after the first event affects the second event. So this is the notation that explains that. So probability of B/A represents the probability of event B after event A has occurred. This is how conditional probability is denoted. So that's conditional probability. Let's look at some examples. So we have the same example. Again, we're being told that the first marble is not replaced, so that changes what's available when you go to draw that second marble. Find the probability the first marble is blue and the second marble is orange. So why don't you try that? You may have realized I had you think through and solve for yourself the exact same problem we did before, so hopefully this came to you pretty easily. Now let's look at the next problem, which is going to be a little bit more complicated. The probability both are different colors. So we have the probability of getting orange and then blue, and the probability of getting blue and then orange. So the probability of getting an orange was 3/5, but then once we take away an orange, the probability of getting a blue is 2/4. You can put 2/4 or 1/2, it doesn't matter. Plus the probability of getting a blue first would be 2/5, and the probability of getting an orange second would be 3/4. I don't simplify my fractions because it makes it easier for your denominators to stay common for when you get to the addition. Again, if you want, you can put some parentheses or brackets in here to show that you're going to multiply first, but you don't have to because of order of operations. So you may realize you're going to get 20 in the denominator of both of these unless we simplified 2/4 to 1/2. So that's why I didn't do that. So 3 times 2 is 6, 5 times 4 is 20, plus 2 times 3 is 6, 5 times 4 is 20. That doesn't always work out, by the way, so pretty, but you will see that both fractions are the same from time to time, but that does not always hold true. So 6 plus 6 is 12, 12/20ths. Now we'll simplify as our last step. So what would we get? 3/5. In this next example, there are 5 cards in a deck, 2 black jacks and 3 red jacks. If the cards are shuffled, one is chosen and not replaced, and then another is chosen, find each of the following probabilities. So the first thing you want to check for is whether this is independent or dependent. What do you think? It's dependent because of what words? Not replaced. Good. All right, so let's move on. So both cards are black. So we want to find the probability of choosing 2 cards where the first one's black, we leave it out, and then the second one is also black. So what's the probability of getting a black card initially? 2 out of 5, right? And then what's the probability of getting a black card once that one is taken away? 1 out of 4. So you can cross cancel. It's good to be in that habit. And then what do you get for your probability of getting both cards black? 1 out of 10. Very good. Let's move down to the next one. In this case, we want the probability that one card is black and one is red. Now it doesn't say what order they're in, so we have to consider black then red, and then red along with red, and then black. So let's start with black then red. So if we were to choose a black card initially, we know our probability is 2/5. We just saw that. So now a black card is gone. What's our probability of a red card? 3/4, right? So then what's the probability of a red card initially before we take anything out? 3/5. And then what's the probability of a black card once one of those red cards is gone? 2/4. I'm not going to simplify the 2/4 because as you can see, 5 times 4 is 20 for both of these fractions, and we're going to have to add, so I want to keep my common denominator. So I'm going to wait and simplify as my last step here. You don't have to put these brackets in, but you can if it helps you visually. Just remember to multiply before you add. So what do you get when you multiply 2/5 times 3/4? 6/20ths, right? And what about 3/5 times 2/4? What do you know? 6/20ths. Now it does not always work out that we have the same fractions. It does a lot, but not always. So keep that in mind. So what do you get when you add 6/20ths and 6/20ths? 12/20ths, right? And what does that equal when you simplify? 3/5.